All right, take a look at your homework. Textbooks open to page 54. Textbooks open to page 54. And you had pages 54 to 55, numbers 18 to 32, the even. We were practicing with multiplying radicals. In class, we said in order to multiply radicals, the radicals must be the same order. Or in other words, they must have the same index, right? They don't have to be similar. When do we need similar radicals, Audrey? To add them. And what does it mean for radicals to be similar, Kendall? Same index and same radicand, both in order to add. But to multiply, they don't have to be similar, which is good. Okay, that makes our life a little bit easier. They just have to have that same index. And that's what we were practicing with on 18 to 32, the even. Number 18, when you initially just multiply exactly as written, Brandon, what do you initially get on 18?
2x times the square root of 100.
Good, 2x times the square root of 100x. And then after we just multiply the coefficients, multiply the radicands, then we see if we can do any reducing. And we don't even technically have to reduce. We've got a rational root here. Yeah, the square root of 100 is just 10. So we get a 10 in addition, or multiplied by, rather, the 2x that's out here to get a final answer of
20x times the square root of x.
20x times the square root of x is correct. How many have that for number 18? Number 20, we have the fifth root of 12r cubed times the fifth root of 3r. When we multiply just straight up, what do we get, Audrey?
Fifth root of 26 times.
And then we're going to try to see if we can reduce. And if this were a square root, hey, I'd be good, right? 6r squared. But it's not a square root, it's a fifth root. Are there any fifths, rational fifth roots inside 36? No. 32 would be a rational fifth root, right? Fifth root of 32 is 2. That's not a factor of 36, and 5 doesn't go into 4, so we're done. There's our answer. How many got it and left it there on number 20? Good. On number 22. Here we can't multiply them the way they're written, Abby, because they don't have the same index. Though, well, trying to think, is there an easier way to do this? There kind of is. There is one thing I see on number 22 that's just kind of like, bam, right there in front of me. Do you see it?
The 81x to the fourth?
Yeah, because I know the fourth root of 81. We've memorized that's class 3. So I'm not so much reducing as just simplifying the radical in the first place. And of course, the fourth root of x to the fourth, there's also the x to the fourth. You said just x, right? So maybe before we do anything else, we just get a 3x and we'll leave the fourth root of the y that's in there. Okay? Maybe we do that. You didn't have to, but it does make your life a little easier. And then we've got this ghastly looking seventh root of a y to the fifth, which you can't do anything about, so you're kind of stuck with it. What's the common index we would have to use here, Genesis? 28. We have to go with 28 roots of stuff, which is, like I say, just ghastly. And Genesis, to go from a 4 to a 28, obviously multiply that by 7, which means I raise the y to the 7th power to, of course, get y to 7. Here I'm going to multiply by a 4, which means I'm going to end up raising this to the 4th power. And this is where our calculators come in handy. Remember that y to the x button on your calculator? We can use that to get 8 to the 4th rather easily. Anyone?
4,096.
It ends up coming to 4,096 when we raise 8 to the 4th. And of course, y to the 5th to the 4th becomes, Genesis, y to the 20. Because when you raise power to a power, you multiply the exponents. Now we're ready to multiply. 3x times 1, that's easy, class.
3x.
3x. And here we're going to keep the index, right? And then y to the 7th times 4,096, y to the 20th, Michael, becomes...
I don't know. I multiplied 8 by 4 instead.
Well, let's not make this too hard. 1 times 4,096?
Oh, yeah. It's 4,096 and y to the 27.
There we go. And this is the final answer we should have had. Now, let's suppose, though, you didn't reduce first. Well, in that case, bless your heart. This is still going to become the 28th root of all of that nonsense. This is going to become the 28th root of, let's see, we've got to multiply by 7, so raise to the 7th power. Does anyone on calculator 81 to the 7th power? It's a really big number. So 81, y to the x, 7 equals. It's in scientific notation. It's 2.287 blah, blah, blah times 10 to the 13th and x to the 28th, y to the 7th. And then we've got to multiply that number times 4,096 to get it. It's a mess. So the moral of the story is, if you see the fourth root of 81, just take the root, Theoretically, though, if you could stick with it long enough, you could end up getting to this answer, but yeah, that's big. Anyone get this answer last night? All right, Abby, good. The rest of you, do you see how it would have been a lot easier this way than that way? All right. Hey, like I've said before, be nice to the math teacher, laugh at his jokes, and this won't happen on a test. Just saying. All right. That wasn't a joke, Michael. Well, actually, kind of was. Number 24. Michael, we've got both square roots. So we're able to multiply them straight up, multiply the coefficients we get.
I got 6k.
No, we're not looking for the final answer. Just when you multiply the coefficients we get.
Yeah, I jumped straight to the final answer.
You did?
Yeah.
Interesting. Why'd you do that?
Because, I don't know.
Well, let's do it small steps here. Small steps, because some people might not be as smart as you. So let's multiply the coefficients to get...
Let me erase it because I wrote over it in my book.
You're Maddie. She's Abby. Maddie! Number 24. When we multiply the coefficients, what do we get? And I couldn't hear all of that, but I'm going to assume you said g k squared p to the 5th. Is that what you said? There's an m squared in there too. I don't know how I missed that. There we go. Is that what you said? Good. And now we can simplify it up, right? We can reduce the 90 by factoring it, class, into 9, 10. Though you may have caught the 9 earlier, right? And see, hey, square root of 9, I'm just going to get that 3. I'm going to make that a 6x to the 5th, just right off the bat. But if you didn't, okay, we did our 3 now to end up getting class 6. And then, of course, I can't do anything with the g, so I'm going to leave the 10. I'm going to leave the g. Square root of m squared is m. And the square root of k squared is k, though technically that goes before m. I got it backwards up here. The square root of p to the 5th, Maddie, but we give a p in there. And then we still have this x to the 6th that's out here and the y cubed that's out there. And so 6km p squared x to the 6th y cubed times the square root of 10gp. And that is the answer that my answer key has as well. How many got this answer with all the stuff? All right, good, Michael. And of course, he can do it in his head. But for the rest of us, questions on how we do it. All right. And Brandon looks over like, I wish I were smart like you. You did? Oh, good. All right, number 26. I'm just picking it. Let's go back to Michael, because all I want is the answer on this one, actually.
It's 3 times the square root of 7 minus the square root of 77.
Good. 3 times the square root of 7 minus the square root of 77 when we distribute the square root of 7. Number 28, how do we multiply those two binomials together? Kendall? FOIL. I'm going to walk through the progression here, so I'm not looking for the final answer yet, but when I multiply the first, what do I get? When I multiply the outer,
4 times
inner, and the last becomes the square root of, which is 2. So I've got 8 and 2 can combine to give me 10, the short E sound. And then the 4 square root of 2 and 2 square root of 2 gives us, and there's our answer. How many had 10 plus 6 times the square root of 2? Good. All right, Maddie raised her hand real. Just kidding, she didn't really. All right, number 29. Again, got a FOIL there as well. Just give me your final, not 29. Try to stay on the evens here. Number 30, when we multiplied those two similar binomials, what did you get there, Genesis?
19 plus 6 times square root of 13.
Let's take a look at number 30 here. Your first, you multiply 2 times 3 to get 6. Your outer?
2 times square root of 13.
Careful, negative 2 times the square root of 13. How about the inner?
3 times square root of 13.
And the last initially is going to give you,
Negative square root of 13.
well, 13 times 13 will be the square root of 169, but that is, of course, just 13. Now, careful here. Because of the signs being different, it is a negative. So 6 and negative 13 doesn't give me 19, but rather
Negative 7.
-7. And then when you combine the negative 2 squared root of 13 and the positive 3, again, we're not multiplying, we're adding them together. So there we go. This is the answer we should have had. So just a couple little things happened there. And the number 32, back to Abby, that I could FOIL. Nothing wrong with foiling on that. But it might be a little quicker if instead I realize it's a pair of conjugates, a sum and difference, which I could multiply to get a
X to the 4th -7.
good. When we square the first square, the last put a minus sign. Now, we call it a difference of squares, but because we were dealing with irrational values, they're not actually squares, but it is like the difference of squares. Square the first square, the last, put a minus sign. How many had that answer on 32? All right, was anyone perfect? Well, I guess the only one who got this nonsensical one right was Abby. How about besides this one? Was anyone perfect on all the other ones? All right, a few of you, all right? Anyone just missed a 2 total? Missed 2 total. It looks like everyone missed at least 1. Are there any questions on the ones that are here? Any questions before we move on? All right, turn over to page 57. Page 57. And there's 2 problems on page 57. It's number 51 and 52. And more practice with FOIL. And I will say this, if there's one process that you really need to get down well, it's FOIL. Because frankly, if you forget how to square the first, square the last, put a minus sign, or square the first, square the last, multiply and double, you can always resort to FOIL, right? Anytime you're multiplying binomials, FOIL will work. So good to know that process. Number 51, what did you get for your answer, Brandon?
Negative 13 plus 7 times the square root of 5.
Great job. Negative 13 plus 7 squared root of 5. Check your work. Negative 18, positive 9 squared root of 5, negative 2 squared root of 5, positive square root of 25, which is just positive 5. Should have been your first, outer, inner, last. And then good job combining. Number 52, what did you get for your answer, Audrey?
Y squared minus 2.
Y squared minus 2. Square the first, y squared, square the last. When you square a square root, class, you get the radicand. That was kind of weak. Class, when you square a square root, you get the radicand. So we square the square root of 2, we just get 2, and then put the minus sign between them, y squared minus 2. Questions on the homework? Let's do some more review very quickly, and then we'll move on. I want you to start with some adding radicals once again. Again, they have to be similar in order to add them. Let's start here with just 2 addition problems. Again, with a big index, make sure you rewrite it as something squared or something cubed or something to the 4th. Write it as something to a power. With fractions, find a way to take the root of the denominator. Otherwise, factor it up. on his first one, the 36 becomes 6 squared. I get the cube root of 6. Here, I want that 27. Take the cube root to get 3. I end up getting 4 times the cube root of 6. I'm noticing a pattern here. What number am I looking for? A 6. Now, maybe it doesn't work out. Like, it's like 6 times, 15. I mean, that doesn't help, right? But it turns out to be 6 times 27. And that does help. Take the cube root to get
3.
Times the 2 that was already here ends up giving me a 6. Times the cube root of 6. I probably wouldn't have thought of 27, to be honest with you, but I didn't have to. The 6 told me what to look for. Again, not that it's always going to be there, but a lot of times. End up getting 3 times the cube root of 6 for our answer. I haven't got that on the first one. All right, finish up that second one now. And then on this one here, let's start with a fraction. Top divided by 2, end up getting a 4. When I take the square root of 16, 4 times the square root of 6. I know there's no 6 in here, right? But I see it's 4 times 7. So I'm like, well, they're not similar here. I wonder what's going to happen here. Well, 216, again, that's 6 cubed. I can take the cube root of that evenly. So I end up getting negative 5 squared root of 6. Combine here to get negative 1 squared root of 6. And then just keep the 6 times the square root of 7, who has no friends. How many got that answer on the second one? All right, questions on adding radicals. We feel like we're good to go on this now. Good. Let's practice a little bit more with multiplying radicals then as well. Make sure we're good to go with that. Again, adding radicals, reduce at the beginning. Multiplying radicals, you don't have to reduce until the end. His hand down. I don't want you to fall asleep, right? Two things we got to stay awake for: morning devotions, math class. a minute and a half or so to finish up. Handle, hand down. Hope you stay wakeful. All right, pencils down. Let's take a look at these together. And Kendall, we'll start with you. If I want to multiply these radicals, of course, they have to have the same index. All they need to multiply is same index, right? Adding same index, same radicand. Here all I need is the same index. I've got it. So I just multiply it. How?
You start with the coefficient.
Good.
So a negative 42.
And then
you multiply the radicand, which is 20. And then radical.
and it stays the same, just stays a square root. And then at the end we see if we can
Reduce.
to reduce, I need to factor the 48 so I get a square.
4 and 12.
4 and 12. All right, pull out
2.
times the negative 42 we already had.
84.
Negative 84 times the square root of.
12.
How many have this answer? Negative 84 times the square root of 12. Ooh, lots of people did it. Questions, comments? Michael?
16 can go into 48.
16 could go into 48. That would be a bigger square. Or let's pick it up from where Kendall left off. We still have a
4 and 3.
4 that can come in. So we just want to keep going, right? Don't stop. Get out another 2 to get what final answer?
Negative 126 times the square root of 3.
Do you mean negative 168 times the square root of 3?
I got 126.
Ah, okay, yeah. So when we factor into 16 and 3, pull out a 4. 4 times 42 should have been a 168 down there. But you saw the factoring. And again, if you show that step, you get most of the credit on this on a quiz or test. How many ended up with this final answer here? Okay, a few more of you that time. Questions on this? Let's go to the next one, and we have a little bit of a problem, Maddie. Yeah, they don't have the same index. This, of course, is a 3. This index is a 2, and it helps to write it so that we see we want what index. So we're going to take 4, and we're going to have a 6th root of something, and we've got 2, and we're going to have a 6th root of something. Here, what ends up becoming the radicand? 25. You multiply by 2, so you square. Here, what ends up becoming the radicand? 27. Multiply by 3, so we cube. And now, we have the same index. Now we multiply. Walk me through. Good. Multiply the 8. Keep the 6th root. And you said... And usually I said it's not going to reduce or rationalize down. 1 is obviously a 6th. That's no help. 64 is a 6th. That doesn't divide. 729 is a 6th. That's too big. We're done. How many ended up with this answer? 8 times the 6th root of 675. Questions? All right, looking at the next one. What should I do to multiply here, Genesis? Foil. And again, I'd like to go ahead and just show all 4 steps of the foil. When we multiply the first?
12 times 3.
Well, 4 times 3 is 12, and then we multiply the radicand. Square root of 2 times square root of 2 is square root of, which is, times the 12 becomes 24. All right, what about our outer? Good, negative 4 square root of 2, and then the inner?
Negative 9 times square root of 2.
And then the last.
Positive 3.
All right, and as usual with similar radicals, we can combine the outer inner together to get,
36.
ooh, careful, you're just adding them. Because we have like radicals or like terms here. And the first and the last can combine together as well to give us, and that should have been our answer here. How many have this answer on this one here? All right, questions on the FOIL. On this last one, we have a binomial squared, and usually we have what 3 steps to squaring a binomial, class?
Square the first, square the last, multiply and double.
However, if you feel like that's going to mess you up, you could write it twice and FOIL it, right? So if you're like, okay, I understand FOIL, write it twice and FOIL it. That said, I want to show what I think is the faster way, and that's to square the first, square the last, multiply and double. When you square the first, you got to square both parts. You got to square the 9, Michael, to get
81.
And you have to square the square root of 3 to get
3.
3. Because when you square the square root, class, you get the radicand. So, of course, 81 times 3 becomes
243.
All right, then we also have to square the last. And when we square the 2, we get
4.
When we square the square root of 5, we get
5.
to get
20.
And, of course, anytime we square, class, we always get what sign?
Positive.
Positive. And then we got to multiply and double. Now, if we just multiply 9 squared of 3 times 2 squared of 5, that would give us
9 square root of 3 times 2 squared. Oh wait, hold up.
if we multiply them, we would get
18 times the square root of 15.
right, 18 times the square root of 15, technically negative, but I was going to try to bring that down in a minute anyway. Negative 18 squared root of 15. We want to double that to make it
Negative 36 times the square root of 30.
ooh, careful. Okay, so remember, and I'm actually glad you made the mistake here. When we double class means you multiply by 2, not times 2 square root of 2. So the 2 rational multiplies by the 18, you get a 36. The 15 isn't being multiplied by a square root of 2, it just stays 15. Does that make sense? And I'm glad he made the mistake. It's got a feeling others of you might have as well. Does that make sense on that? And then for a last step, we'll combine these two rational values to get, Michael.
263.
And then we'll have the negative 36 times the square root of 15. Again, if you were to FOIL it, you'd have gotten the same answer, right? Just 4 steps written out, and that's perfectly fine as well. How many got that answer on the last one? Okay, only a couple of you. Questions on that last one? Any questions? Going once on questions. Going twice on questions. All right, next section in your notes, dividing radicals. Dividing radicals. I just like messing with people's minds. Dividing radicals, next section in your notes. Oh, wait, my notes say I'm supposed to give a quiz next. I'm just kidding, these aren't even my notes. Dividing radicals, next section in your notes. I have way too much fun at my job. Dividing radicals. You need the same index. You probably would have guessed that, though, considering division, just multiplication by a reciprocal. So since they're tied together so tightly, whatever's true of multiplication is going to be true of division as well. And you probably could guess the steps. Step number 1, divide the coefficients. Step number 2, divide the radicands. Step number 3, leave the index alone. Don't go trying to divide those indexes or anything. And number 4, reduce if possible. Basically, the same steps we had for multiplication, except they say division. There is one important detail, though, and this is also going to sound familiar. You can multiply anything together, but you can't always divide, right? If you cannot divide, write this down for steps 1 and 2. If you cannot divide, reduce. If you cannot divide, reduce. And we're going to write division as a fraction, so it's going to be easy, I think, for you to see the fractions that form, because that's how we write our division problems. Write this first one down as an example on your paper. The square root of 44 divided by the square root of 11. Now here there are no coefficients to divide. Well, technically there's ones, I suppose, but 1 divided by 1 is 1. We won't worry about it. We just divide the radicands. Square root of 44 divided by square root of 11, class, equals square root of 4. Easy enough? And then, of course, we don't even reduce it. We just take it, class.
2.
2. It's rational. Easy enough? Divide coefficients, divide radicands, leave the index alone, reduce if possible is that last step. Sorry, back corner having trouble seeing. Reduce if possible. All right, this example down. 3 times the square root of 15 divided by the square root of 3. Divide the coefficients. What do I get when I divide the coefficients, class? 3. What do I get when I divide the radicands? A 5. And we're going to leave the index alone, so it's going to be a square root of 5. And then I see if I can reduce, but I can't, so I'm done. Got this? Okay, good. Write this one down. Cube root of 5 divided by the cube root of 40. Wait a second. Can we divide 5 by 40? So I'm going to imagine this as a fraction, 5/40. And I'm going to reduce 5/40, class, to get the cube root of 1/8. Now we go back to our reducing radical thing. And you see, this is one that's going to come up a lot, isn't it? Because we're going to generate fractions just by default. So we're going to have to be able to take the root of the denominator. But can you take the cube root of 8, class?
Yes.
Yes, trick question. What's the cube root of 8, Brandon? 2. Can I take the cube root of 1, class?
Yes.
Yes. What's the cube root of 1, Brandon? 1. And I'm done. 1/2. Comes out rational. She just contradicts you. She doesn't even know if you're right or not. She just, whatever Brandon says, I'm going to say the opposite. Worked out great for you that time. All right, write this one down. 10 times the square root of 10 divided by 2 times the square root of 15. I try to divide the coefficients. 10 divided by 2, class. 5. I try to divide the radicands. Wait, can you divide 10 by 15? No, so think of it as a fraction, 10/15. Audrey, that'll reduce to the square root of 2/3. So we get 5 times the square root of 2/3. Again, if there's a coefficient in front of the fraction, I'm going to put that over 1. 5/1 times the square root of, and 2/3 is no good, right? I reduced it to 2/3, but I need a denominator I can take the root of, right, Genesis? So I want what number down here in the denominator?
9.
A 9. So to get a 9 top and bottom by 3 gives me what new fraction? 6 9ths. And so again, I'm going to keep the 5/1, and then with the fraction, class, we take the root of the denominator, and I can't take the square root of 6, so just leave square root of 6. And now for my final answer, I can put the 5 times the square root of 6 in the top, 1 times 3 in the bottom, just 3, because it didn't cancel with the 5. Oh well, there's my answer. 5 times the square root of 6 over 3. You could also say 5/3 times the square root of 6, but meh, just leave it that way. Questions on this example? All right, do we see what I mean by if you can't reduce, treat it like a fraction, reduce the fraction, or if you can't divide, treat it like a fraction, reduce it down. Questions on this? Again, a lot of root of the denominator type reducing here. Write this one down. 4 times the square root of 15 divided by 10 times the square root of 6. 4 times the square root of 15 divided by 10 times the square root of 6. What am I going to have to do here, Brandon? Reduce the, starting with the coefficients, 4/10 becomes 2/5. And I can't divide the 15 and 6 to get the square root of some integer, so I'm going to have to get the square root of some fraction, but I'd like it to be a reduced fraction. Maddie? I can't, so I'm going to think of this as 15/6, and I'm going to reduce that. 5/2. Now it's really tempting, class, to be like, ooh, cancel the 5s, cancel the 2s. Can you do that? No, because this 2 is a rational 2. This 5 is a rational 5. These are irrational. But I can take the root of the denominator. So now what, Maddie? To get, instead of 5/2, 10/4. And I'm going to leave for now the square root of 10, right? Because I can't take the square root of 10, but I can take the square root of 4, 2. And now I can actually do some canceling. I couldn't here, right? With that 5 be quiet. All right, with the 5 and the 3, right? Nothing cancels. But here I can do a little canceling, Maddie. The 2's to get a final answer of the square root of 10 over 5. Questions on this one? Okay, granted, we started off with a stupid easy one, right? They're not all as stupid easy as the first one we did. A lot of them will kind of be like this, but again, follow the process. If it doesn't divide, reduce the fraction. Doesn't divide, reduce the fraction. Do what you know to do. I'll write this next one down if you would. The square root of 3 over the cube root of 2. The square root of 3 over the cube root of 2. And just like multiplication, gotta have the same index, and I don't. So I'm going to change both of these so that they have what kind of roots here, Michael?
6.
6th roots. So I'm going to go with the 6th root of
27.
27. Again, 2 times 3, so cube it. Divided by the 6th root of
4.
4. Square it, and since I can't divide, I'm going to treat it like a fraction. I can't even reduce it. I end up just getting the 6th root of what fraction, Michael?
27 over 4.
27 fourths. Ugh. And somehow, I've got to take the 6th root of the denominator. But I can't take the 6th root of 4. 6th root of 1 is kind of, we're already past the 1. So what's the next number I can take the 6th root of? 2 to the 6th.
64.
64. 2 to the 6th would be 64. If that didn't work, maybe 3 to the 6th, 729. If that doesn't work, 4 to the 6th. I think it's like 4,096 or something like that. You just keep trying things. Can I make this into a 64 class?
Yes.
Yes. If I were to multiply top and bottom by
16.
16. All right. So we get the 6th root of how many 64ths, anyone?
432.
432. And, well, I can't take the 6th root of 432, so I'm going to leave the 6th root of 432 all over the 6th root of 64, which is just 2. And there's my ugly answer. Questions on that one? Do you see how it's similar to the idea of multiplication? Right? Got to get that same index, right? Same way we did before, but division process leads to fractions. Questions? Write this one down if you would. The cube root of 9x squared y divided by the square root of 3xy. The cube root of 9x squared y divided by the square root of 3xy. Once again, Genesis, I don't have the same. So I've got to make a match, and I'm going to turn them both into 6th roots again. That's my favorite, because cube roots and square roots, Anyway, so 6th roots, right? So to go from a 3 to a 6, obviously multiply the index by 2. So what do I do to the radicand? Second power, right? Raise it to that second power to get. And then in the denominator, to go from a 2 to a 6, I multiply the index by. So what do I do to the radicand? Cube it to get.
27.
And let's see, I've got to try to reduce this fraction. I can reduce a little bit, right? For instance, the 81 and 27, I can reduce both of those class by 9 to get in the bottom, and oh, I can actually reduce that even more. 9 and 3 could reduce to just give me 3. Okay, that worked out. So I actually divided to get a 3. How about the x to the 4th and the x cubed? Class, divide that to get x. And the y squared and y cubed is going to leave me with what, class? A y in the denominator. At least it's not a big number, right? Because I know what I need to take the 6th root of. Not y, but y to the 6th, right? If I had a y to the 6th down here, I'd be in business, right? So multiply top and bottom by y to the 5th. I've already got one of the y's. I just need 5 more to get a 3xy to the 5th here in the numerator. And we'll keep the sixth root of the 3xy to the fifth, and in the denominator, the sixth root of y to the sixth, class, just y. Questions on that one? Questions? Let's do one more. I think we've got, I don't know that we have time for one more. We'll hold off on those last two. We'll practice more on Monday in our next lesson. Homework for this evening. I'm actually going to give you 4 problems to write down. So maybe in your spiral notebook, set up where your homework's going to go. We need 4 problems on the chalkboard to work for homework, and then just a little bit in your textbook. We're going to have 3 times the square root of 24 over 9 times the square root of 6. 15 times the square root of 2 over 5 times the square root of 8. 4 times the square root of 2 over 2 times the fourth root of 6. 2 times the square root of 3 over the cube root of 6. In addition to all of this, do page 55, numbers 37 through 40. Also worth noting, there's a test coming up in lesson 36. Test coming up in lesson 36. Once you have that copy down and the bell rings, you'll be dismissed. Have a wonderful rest of your day.